Okay, so moving forward to the sea level change during the so-called Pleistocene epoch. In India we say epoch, in America some people say epic. I don't know, you can say whatever you want. So Pleistocene epoch and today. Pleistocene epoch basically went from about 2 million years ago. If you remember the first chapter, we looked at the geologic periods, eras, eons, and so on. Pleistocene is the most recent ice age period you can think of. It was not one long ice age, but it had about 8 or 9 ice ages. The last one started about 120,000 years ago and ended about 10 to 12,000 years ago, and it was critical because the end of the last ice age basically started the modern human being's evolution as an agricultural, family-oriented, moving away from hunter-gatherer to settling down and building big families. Land use change because of agriculture, population increase because of families, because you settle down, you have more kids, and so on and so forth, right? So from about 2 million years ago to about 10 to 12,000 years ago, there was a series of ice ages that affected the sea level and Earth. The continental configuration hasn't changed dramatically in these periods, other than that the Himalayas the Himalayas keep rising because the Indian subcontinent pushes into Asia, Australia moves forward, and all the continents are actually moving northward at a very low speed, but some are moving faster, like Australia at almost 3 centimeters per second and so on. Okay. The sea level during the last ice age, look at this figure here. So we are going back in time, as I said before, I think. The paleoclimate people who study past climates, paleoclimate, tend to plot the time axis backwards. So it is the present here, 10,000 years ago, 20,000 years ago, 30,000 years ago, and so on. So the maximum of the last ice age was reached around 18,000 years ago, which is shown here as the glacial maximum. That's when the extent of glaciers, especially in the northern hemisphere, was the most extensive in the most recent ice age. So they came down all the way into New York, in Europe, in Asia, and so on and so forth. So if you build that much glacier mass on land all around, obviously you're going to take out a lot of the water from the ocean and put it on land and freeze it up. So the sea level was at least 120 meters below today's sea level. So you can see that the sea level, if you consider today's sea level as the reference point of 0, and if you go back to when the ice age was still going on, so more and more water was still being moved as by evaporation and snowing on ice, glacier that already existed, and the glaciers kept growing. Then the sea level was somewhere here. Because there was already glaciers, this was lower by, let's say, about 10 meters. This is in meters here. And it kept decreasing as the glaciers kept growing, and at the glacial maximum around 18,000 years ago, it was 120 meters below today's sea level globally, which means a lot more of the coastline was exposed, because sea level 120 meters is a lot of sea level. Okay, if you imagine suddenly the Indian Ocean drops by 120 meters, Indian shelf is going to be exposed for a couple of 100 miles. So that's a big change, right? And the ice age ended because of changes in the orbital forcing again. Human activity was not the cause here yet. So the natural variability or natural change in forcing began to melt the glacier. The glacier kept melting and sea level kept rising, and here we are where we consider this today's sea level as some kind of a reference level. On top of this, we will look at just the last couple of 100 years to say that since Industrial Revolution, global warming has happened, glaciers have melted, thermospheric changes happening because ocean is warming. Hence, sea level has risen, but nonetheless, approximately speaking, today's sea level is somewhere here. We considered it the 0 level for reference, and in the past sea level had dropped by 120 meters and it has risen now to the current level. With global warming, we continue to melt the glaciers on Greenland, for example, and Antarctica. How much sea level is locked up in those glaciers, and if they melt, how much will sea level rise? Or even before they melt, even they are melting as of now in some places. Greenland is going really fast. Remember, sea ice in the Arctic can melt, but that will not change the sea level, because it's like having a cube of ice in your Coca-Cola, or we won't mention alcohol. If the ice cube melts, the level will not increase. Why? Because the ice in fact has a little bit larger volume than the water. When it melts, it in fact should reduce, but we won't notice the change. When you melt the glaciers, which is locked up on land, and you are releasing new water into the ocean, so that's going to raise the sea level. So you have to watch closely how Greenland and Antarctica are melting, and how fast they are melting, and how much the sea level will change when they melt, let's say by the end of 2100. That's kind of a baseline we're using these days, but honestly a lot of other things will happen before. Nonetheless, sea level change is already happening. Sea level is already rising, as I already mentioned, because land is sinking in some places, but thermospheric expansion is going quite fast in some places. But remember your ocean dynamics. So sea level rise is not going to be constant, the same everywhere. The dynamics is going to keep it low in some places but high in some places. So it's important to know where it's rising and how fast it's rising, and where it's not rising. Correct? So complicated, but nonetheless important. So you have to keep carrying your concepts and make sure you explain things properly to yourself and to grandma.